lower attendance than maybe because we are coming towards the end of the session, I guess. So for those who have joined newly, especially for you, Rome, what I would like to say is, a couple of things, right? The first thing I wanted to talk to you about is what is this community all about, right? So our community is, it's not like a company which is run by an employee. It is like all the volunteers, we come together, we run this as a people-led grassroots movement and open community, and we govern ourselves. And one person trains other person trains other, and that's how we grow this community together, and mostly through the word of mouth. That's what the Testoper community is all about. We help people to develop their future skills and innovation and so on. So if you are new, there's a couple of things that you can really do. First thing is you can join our. Mahendra, can you post that in WhatsApp, please? Yeah. See, if you see here, those who have not joined newly, this is the procedure that you would probably go through. So we have a WhatsApp group, so you can join that closed WhatsApp group for the Codeathon members. Then you can provide your first name and last name and email address. What we normally do is we try to get you into the onboard into the Microsoft Teams that we have, which is what that I'm showing. Can you see my screen, by the way?
No, I think I've started sharing.
Just a minute, Partha, let me finish this one, okay? And then I'll give you the control. So if you actually look at the screen, my screen, hopefully now you guys can see it. So those who have joined newly, once you provide your first name, last name, and email address, we can actually add you into this collaboration platform. So you can collaborate with each of us before and after. For example, if you wanted to ask questions to Partha and so on, you can do that. And we also trying our best to accelerate this jobs channel and the tech teaser channel. So what we wanted to really do is in the job channel, whoever has a requirement for the jobs, we wanted them to put it from their company and then help to give other person referral. So, the community members can benefit from each other. We kind of started this, and we are trying our best to see how we can, make this more usable for all the community members. And then we also have another channel called Tech Teaser, where we wanted to put some news related to the latest things that's happening on the tech, because we are a startup a year old. It's picking up slowly, but if you guys can join and help us to grow, that would be really good. So end of the day, you will get access to this community, and you can collaborate with each other. And Justin, the project that I was talking to you about is this Testoper project, right? So we have few teams that they are trying to come up with an idea and building together some amazing idea. And during Friday, we try to help teams to learn more on what are all the skills that they really need to become as an entrepreneur, right? And not only from the developing from the coding skills, but also from leadership, teaming, and many other things that we try to do on that session. And you can always go to the Eventbrite and you can look it up, different programs that we do, and you can register. And one kind ask that I have for you all is, if you have not done so, please register for the meetup that we have that's coming up on March 20th. I would like to see you all joining that meetup. Okay, so those are my governance word. Partha, I wanted to give you the floor, but at the same time, I wanted you to sometime stop in between, and we all of us, including you, me, and all of us, have to fill up this survey for today.
Okay.
This is the process that we do. One session before the closing of the session, closing of the topic, we do this. For those who joined newly, by the way, this cloud computing and DevOps fundamental, today is our 5th session. We have one more session on next week, same time, and that ends this particular topic. Those who have missed the previous session, you can always go to the YouTube and search Testoper, and there's more than 90 videos are there. You can always look up this topic and learn the previous sessions, missed sessions, right? Not only from this, and also the previous topics and previous sessions you can learn from the YouTube. So having said that, Partha, over to you.
Okay, thank you. Okay, last week we actually I wanted to do a little bit of theory behind DevOps and some of the fundamental learning behind DevOps before we get into actual demos, and we didn't get a chance last week. So I'm going to sort of lead our way into it with discussing what is DevOps and what it means to be a DevOps ready organization, or a DevOps practicing organization, or a DevOps practicing team. So, in normal software development, this is what has been happening. Even today in many organizations, this happens that you have a development team, you have a test team, you have a release team, and then you have an operate team. And the development team passes the code when they are ready to the test. The test then passes the code to the release team, and then the release team passes to the operate. And then from the operations team, the development team gets back some feedbacks from bug reports, some new feature requests that customers have come up with. And this causes a lot of grief in the whole organization and in the whole software development cycle and in the progress of the organization itself, because this is a very long and um, non incompetent or not a very efficient way of doing things. So if we look at what is the competitiveness of this whole thing, you can never with this model really go and continuously tell your customer, I am better than any of one of my competitors, because I am able to deliver the features you want very quickly, rather than you wait 3 or 4 or months or 6 months for a new feature to come through. And what has happened is software companies, like what Justin was speaking about some time back, they are now starting small teams and starting to put everything on the cloud, and starting to use agile development methods, not only in development alone, also in continuous integration, continuous delivery. And so this process that we are just seeing on the right is not fast enough. And that's how organizations become uncompetitive, and you lose your customers to somebody who's more agile, who's more responsive to customer needs. So, what is DevOps? It's a sort of a combination of different philosophies of software development, practices, tools, and the whole idea of it is to deliver applications at the highest possible speed that you can. You know, you should be able to do it at a much faster pace than your competitors. Uh, those who are using the traditional software development methods or infrastructure management processes, you should be able to do it faster than that, high velocity. And how do we do that is the whole point of DevOps. So the not only competition from people who are doing it much faster, because of the whole concept of microservices also put a lot of pressure. So we already have seen this. Even though we go into even though an application may be broken down into microstructures, microservices, and you have an application that is composed of components, the problems of agility in testing, agility in deployment, agility in operations, getting feedback into the development team, and development team delivering the bug fix or the new feature fast enough, those things still remain. The microservices architecture or the microservices based application alone does not solve the agility problem. You still need to address what is called continuous delivery. It's not only address it, you need to fully embrace it as a team, which means continuous delivery automatically means you have to have continuous integration, continuous deployment, continuous test. How do we achieve that? Because no longer are this our separate teams for dev, test, or deploy, operate. It's not functioning. It's not giving you the competitive edge that you require. So this term is very, very important. Take ownership of the product. That's a very important part of DevOps. You no longer have a development team, a test team, deployment team, and an operations team. You have one team that is product centric and takes ownership of the product. So the team will consist of development engineers, test engineers, test people, you'll have deployment people, and you will have operations people all working in the same team. There will only be one team that will be product centric, and every one of them is responsible for delivering the product in time and with all the accuracy and bug freeness that is that they can achieve. And this strong collaboration between all the different areas of product development and product delivery is what is called the DevOps culture. Any place, any organization, any team that you enter where you have DevOps as a separate entity, test as a separate entity with a separate manager, uh, that is team is not following DevOps culture. They may be calling themselves DevOps, they may be doing DevOps functions, but they are not following DevOps culture. Amazon's executive has once said, very famously said, you build it, you run it. So when a production error occurs or a production outage occurs, it should be the development team that should be paged and called to fix it, not the operations team. So what happens in a DevOps culture with a team that is product centric? This is what happens. You have continuous integration, continuous delivery, continuous operations, continuous learning, continuous sharing, continuous innovation, continuous planning, and continuous testing in every phase of this cycle. And the feedback loop is also continuous. The feedback as from each one of these teams back in the reverse direction is also continuous. You must have this running smoothly for a team to call itself for that they have embraced DevOps culture and are product centric. This, if you don't find this in a team, you can they have things to improve. So what is the core conflict that DevOps tries to solve is this. So the development is the wants to respond rapidly to whatever is coming from the customer and the production operations, and they want to deploy whatever changes they're bringing in as quickly as possible. But operations has a responsibility for providing a stable service, and they would prevent introducing any change that could jeopardize what they are delivering to the customer, because they are directly being held responsible for any production outages. So this has to, I mean, this is a core conflict, because the development and test team on the left want to deliver it as fast as possible. Operations wants to keep it as stable as possible. And if these teams are separate, there automatically there will be conflicts. Okay, so the whole ethics of DevOps is there is a better way of doing this whole thing. So all these things have to be incorporated into the DevOps culture. So there's a culture which is systems thinking. Think of the software development, test, operations, deployment operations as one system. It's one system that is working to deliver the software into the production environment. It's not separate systems working independently. And then take up automation as much as possible. Be lean. Adopt lean methodologies. Eliminate waste. Deliver fast. Continuously keep measuring what you're doing. Collect, analyze data, continuously improve your processes, and then continue sharing feedback and share knowledge. Don't keep knowledge confined to yourself or a few people. Let everybody in on the knowledge. Everybody must learn, and everybody must continuously learn. And that gives you this agile DevOps. All these things together only. Okay. So what are the DevOps areas? We saw this slide very briefly last time. So infrastructure automation. So we are talking of automation and how quickly we can stand up the test environment, let's say, of what we need, or even a new development or a new deployment environment for production purposes also. If you look at a bank like Tangerine Bank or Equitable Bank, or these are the most, I mean, banking is one of the most ancient Western Association has been around for many, many years now. And banks are supposed to be the most conservative of software environments uh, because of they protect your money, right? So we expect banks to have their own infrastructure. We expect banks to have their own software development teams that uh, work their own data centers. If you look at TD Bank, they have two data centers. One is in somewhere in Newmarket or somewhere. The other one is in somewhere in Scarborough. So there are dual data centers. Similarly for Royal Banks, similarly for any of the banks. But Tangerine Bank is a completely on the cloud bank. They don't have any offices. They don't have any data centers. Similarly, Equitable Bank. There are quite a few online banks that just don't have any infrastructure, don't have any compute systems running in their own premises or something. So that's one thing. How do we stand up any of systems quickly, and whether it is on-prem or whether it is on-prem is the term for on-premise, whether it is in our own data center or it's on the cloud, how do we do it fast? So these are the tools you would use: Terraform, Ansible, and there are a couple of other tools too. We definitely need a soft code versioning system. So GitHub, GitLab, Bitbucket, the older systems that have been around for some time are SVN, the Subversion. And there are even older systems that are around. Some companies still use them, but mostly today people are sticking to GitHub, GitLab, or Bitbucket. You must have CI/CD tools running. So Jenkins is the long-standing one. The oldest one, GitLab, has come up with their own CI/CD. They call it GitLab CI/CD. And then the most latest one of them is GitHub Actions. You don't need any of these tools, neither Jenkins nor your any server to run it. GitHub Actions will just GitHub itself will you can put actions, and GitHub will provide the engine to run your GitHub Actions for continuous integration, continuous deploy, build, and all that. Containerization is another thing that has to be embraced if you want to do things fast and do things in a stable way. Configuration management is one of the biggest headaches of any operations team. How do we maintain the configuration consistent across the 300 or so servers that we're having? So Docker helps in that case. So you only manage one platform like Kubernetes or OpenShift, and all your Docker containers are built and they don't change. They don't have a configuration shift in terms of what is the operating system running, what are the patches to be applied, and all that. And so that Docker helps in that. So we'll see a few of these as demos today. Okay. So we talked of Terraform as a tool, and Terraform has been around for quite some time. It has evolved from early days, and it has become much more widespread in use, and also very function rich. So what is infrastructure as code? We have to manage our virtual machines or our cloud-based virtual machines by doing everything we need to do with them, including standing them, creating them, managing their configuration, managing the users' creation on them, and all of that completely through code. Nobody needs to go to the UI to act of the, let's say, Amazon cloud and create a VM and then, or create a web server and then do things with it by transferring files and setting up routes and all that. All that should be done within by writing code. What are the advantages of it? Firstly, it is speed, of course. Where you can do it quickly within few minutes. Consistency. Then today I stand up something, tomorrow somebody else in the team stands up the same machine, and we both have different levels of knowledge, different levels of expertise with, let's say, AWS cloud or Azure cloud, and we don't do it in the same consistent manner. So you have two systems which are supposed to be exactly the same, but they are not exactly the same because of different people setting them up, and different people I may make a mistake in my whatever I am doing on the UI. I may do some mistake in when I'm interacting with the machine and so on. Accountability is another important aspect of this. When you store the configuration in a code repository, if anybody changes the configuration, you know who has changed it, when it was changed, and why it was changed. So there is some accountability there, and there is also, you can put in reviews. If any code change occurs, you can have a review before it is actually checked in and committed and merged with the master branch. And economic. So when before the days of virtualization and before the days of cloud, people used to guard their test environments. I have guarded my test environments. I don't want to lose my test environment because I have built up a lot of stuff in the test environment, which is pretty hard and tough to redo. If anybody has installed, let's say, Oracle or DB2 database on a system and then try to configure it to work the way you want it to work, and then put the schema on it, and populated it with some sample data and all that, it takes days and days to do that manually. If you can do it in if you can capture all of that in a code and just run the code and get it done with probably half an hour, 1 hour or so, then you don't need to guard your environment. You use the environment. As soon as the testing is over and you think this environment is no longer needed, trash it. You can always set it up again. And secondly, you can scale it. If what if I want a high availability database server which I need to test? What if I need 3 databases and I need distributed transactions to be tested? So scalability and all this is managed automatically. You don't have to repeat the same thing 3 times and spend a week or so setting up your system to do your tests. So last week we saw this example from setting up an Azure Kubernetes service on Azure system, and we saw that as code. I don't know if do you want me to run through this again, or we're okay with what we did last time? Anybody? Kader, do we have enough new people to run through this again?
I'm new. I didn't see it last time.
Yeah,
but
please do.
so Partha, I mean, it's totally up to you, right? So you have 1.5 hours and you might have to give me 10 minutes, right, to end the session. So if it is already recorded in the YouTube, you can always refer the people to go and see in the YouTube if you believe you have a lot more to cover.
Yeah, it's covered there. So we'll have another example to go through. Let's not go through this. Let's go to the next one. Okay. This is on Google Cloud, not on Azure Cloud. So what we're going to do is we're going to provision a VPC and some subnets and a NAT router on GCP, and everything is done in code. So this is basically the code. You've got a As you see here, Terraform, you just have to say what is the provider you're going to use. Since I'm using Google Cloud, I'm going to say that's the provider. Everybody's able to see my screen? Is it visible? Do you need a...
Yeah, can you maximize it, please?
Is that okay?
Yeah, better.
Yeah.
Okay, so so the main file just declares the provider and then gives the credentials of the provider, which is in a file. And I'm giving you some, I'm also declaring some variables that I'm going to use. And then the actual creation is done in a module. It's not in this file itself, it's in a module. And the module is here under the modules. So the VPC main is the one that creates the VPC and creates the subnetworks. So a VPC is created, a subnetwork is created, one subnetwork, a second subnetwork, a third subnetwork, and a fourth subnetwork. Four are created. A router is created. A router is given an address, and then the so and you're getting output of what is the subnetworks, what are the IP ranges. I mean, you're connecting the subnetworks that have been created into the router so that the NAT thing works and you get everything done. So that's a very simple Terraform file. And the variables we are using, we just we saw two in the main. We saw that, sorry, not this main. This main, we are asking for three variables. One is called project, one is called region, and one is called zone. And these are given in here in the TF vars. The TF vars file is where you give the actual values for that. The project name is Uni project, region is US West 1, and zone is US West 1B. And I'm going to, I mean, this script is going to create a VPC called this uniproj dash VPC, and it's going to be within the same region, within this region itself. And the routing this VPC will permit is only for this region. Okay, I need to jump to the oh, that is webhooks. Okay. That's my Google Cloud interface. Let me expand it a little. There you go. So I have a project here which is called Uni Project 32470. And that's the project I set here, Uni Project 32470. And under this project, we are going to create this VPC. So do we already have a VPC there? Let's look at that. VPC, PC networks. So note, I mean, make a note that this is still in the same project. We are in the same project. We can shift projects, but we are in the same project yet. And the VPCs for that, or there's one default VPC. Whenever you create a project, Google automatically gives you a default VPC. We don't have any other VPCs. Now what we're going to do is we're going to run this Terraform code that we have. And that's my command window. So this is where my main and my wrong. That's another project. So this is what I have. GCP VC main. And then under modules, if I look at LL modules, I have the network module, and under the network module, I have my VPC main.tf. So how I run this is, normally I have to do a Terraform init, but I've already done that. Well, let's do it again. Too many R's. So Terraform has been successfully initialized. The next thing we do is Terraform apply. It goes through the whole, all the files, and says that this is what I'm going to do for you. So it says I'm going to, tells me all that it's going to do. So it's going to create a VPC, create the subnetworks, and yeah, it's going to create, that's the range, and it's going to create a 1004 subnetwork, a 1002 subnetwork here, 1006 subnetwork here, and so on. And then it tells me I'm going to apply 9 changes, 9 items that I'm going to create, and do you want to proceed? I say yes, and there it goes. So while it's working, let's continue to have a look at the default is already there. Now we got this new VPC has been created. There are 4 subnets that are created here. 10.0.0.23, 10.0.20, 10.0.40, and 10.0.60. They are 4 private subnets have been created. If you go into each one of them, you can get some private Google access is on for 0. Zero and 2, both private is on. For 4 and 6, private Google access is off. So that is how it has been set in the Terraform files that we do. The other item we'd like to see is, are we, sorry, even in this, probably we can see that. External IP addresses. So have these external IP addresses, firewall routes. So all this stuff has been created in a few minutes without somebody having to go to the UI, creating each one of them separately, setting all the configuration, and let's see if we can see the router. So this uni router was created and it is running. It was created by the and see, and it's all the subnets are connected to it. Private subnet 3 and private subnet 4. So these are the there's 4 and 6 were the ones that have private, I mean Google access. And well, so that's part of the magic of using Terraform to so anytime I need to stand up another VPC for another project, all I need to do is just change the project here, change the region, change the zone in which I want to create, give the project name, and run through the same thing. The network module that has been created here, that is here, actually can even be called from a completely different Terraform main. So this can be called from anywhere, actually. So it lends itself to modularization and reuse. It gives you a lot of consistent speed, consistency, and accountability because the code is now in GitHub. It's actually in Testopa GitHub, and I have uploaded in Testopa GitHub. You want to see that? Maybe it's not this. Which repository did I go to? Can somebody remind me what is a Testopa's repository? Yeah, there you go.
Yeah. Cloud computing.
This is only the AKS cluster. Okay, I haven't uploaded this code into this repository, but I'll do it by the after we finish the session today. So you'll have both this AKS cluster Terraform files, and under the same, I'll separate this as a separate folder and put another separate folder, and so that you have both Terraform samples in one folder. One for the AKS cluster, AKS Kubernetes cluster, and the other one for what we just saw, VPC in Google Cloud. Okay, getting back to what we were looking at here. So this is a very small explanation of this file structure. You may look at this and get to know. As prereqs, I'll put some README also. As prereqs, you need to have of course, you need to have a Google Cloud account. You need to create manually. You need to create a. I didn't go to the trouble of using Terraform to create a project and set up the JSON key for it. But that you have to manually do as a prereq for this. You have to set up. You have to create a project in the Google Cloud. Which browser was that? It was the Chrome browser. So you'll have to go to anyway, I don't remember off the top of my head how to create a project right now. Something like not net services. There you go. So cloud resource manager or something. So you can create a new project. You have to create the project, and then you have to create a key for it, and then you go ahead and can delete building settings. So that's a prereq for running this code that I'll put into our test over cloud computing shortly. Coming back to what we were doing with the presentation here. Okay, the next, going back to this slide, you need this slide. Okay. So we looked at infrastructure as code. We look at CI/CD tools. That's another very, very important area of how we manage speed and agility and do continuous integration and continuous testing. So Jenkins is a very, is a tool that's very popular and has been around for a long time. And because they've been around for a long time, there are a lot of plugins for Jenkins, which integrated with many other different tooling and many different ways of application development. So they have a Maven plugin, they have a Java plugin, they have a GitHub plugin, you've got a GitLab plugin, you've got a Bitbucket plugin, so that you can work with these different repositories without going through hoops. So how do we do Jenkins? See, the best and simplest way of running Jenkins is run it as a Docker container. So that sort of gives you a clue, or gives you a segue into one of the DevOps tools in the DevOps toolkit is Docker. So you have to have Docker as a toolkit, because anything you want to do, you can have a Docker container that does this. So if you go to this URL, you come to this Docker. And how do you run this Docker? You can start up a Jenkins container with this simple command, docker run. I've given it port 3019 to run on. And this part of it is for running slaves. If you need to run slaves, that's not going to be part of this discussion today. And once you run this, what you get is a Docker, a Jenkins running on your local system, which you can then, you have to first configure it, you have to set a password, and then you have to download all the plugins, install all the plugins, and then you can create your own jobs, and then you can run the job and look at the console output and so on. So not sorry. So I have a Jenkins running here. This is not running on my local machine. I just chose to run it on one of the VMs that I am working with. This VM is on Amazon Cloud. I wanted to show how this continuous integration is done. Okay, and one of the ways continuous integration is done is immediately as anybody checks in code into a GitHub repository, into your code repository, Jenkins should automatically pick up that change and run the whatever you want it to run. It may be just a compilation and see that compilation is doesn't fail, or it could be just linting. You could just do if it's some YAML file you're checking in, you may need to do a linting on it so that the YAML is well formulated and doesn't not cause grief. when you actually use the YAML in some deployment. And so I've set up a job here, which is called a webhook job. Now, this webhook has been configured to use a GitHub trigger to poll the Git and get whatever is the change, and then do whatever the Jenkins file in that Git tells you to do. So the repository that it is pointing to is the same repository that I just showed you. This is the code samples repository and the testing branch. And the file that is going to run is called Jenkins file. So we'll just look at how this webhook is set up. So so not I'm in the testing branch. Do you need this? My screen is visible. You want it expanded? Okay. The next slide actually shows this view. What you have to do whenever you want to set up a webhook is go to the repository and then go to repository settings and webhooks. And then you add a webhook. This is what adding would entail actually. It will ask you to put your URL, which comes from my URL here. That's my URL. This URL. If I copy that, I'll get the HTTPS also. So and I have to add this at the end of the URL, GitHub-webhook. The content type will be application JSON. We'll look at the what content is being sent. And you have to select what you want to actually kick off the webhook action. So whenever a branch or a tag is created, whenever a push is made, so you can actually select which you can actually say just send me everything. Also, you can do that. Will be a little overkill. But typically, you should do any branch or a new tag is created. Do that. Definitely on your push requests. Whenever you have a push to repository, and whenever a new repository is created. So these are some of the things that you must set up. So I'm just going to update the webhook. What does a push look like? This is what a push looks like. Whenever something I check into the, this is the header of the application JSON content that is sent. It is an application JSON content, and it sends a bunch of information which basically Jenkins will interpret and do what it needs to do with it. So how does this webhook actually work? If we go to, let's go back to our repository. We are back to master here. And let's go to the CI/CD part of it, not the CI/CD part of it, sorry. Okay, let's leave it here. We will make the changes here. If you look at how many runs of this webhook job has run, we have something ran on February 25th, something on, and then the last run was on March 2nd. Now let's go here, and to just kick off some change, I'm going to make a small change to the Jenkins file, let's say. So I'm going to go into the Jenkins file. I'm going to edit the Jenkins file. It's a very trivial edit. I'm just going to echo something to the screen so that we can see the message in the logs. That's it. I commit this change. And I go back here. I just want to see what is going to happen now. And there, a new job is kicked off immediately. And that runs. And if you look at the log, so is that actually visible to people?
Yeah, I can see.
Yeah. So that's the simple explanation of, a simple demonstration of how to set up a webhook. So what happens with the webhook is anybody who checks in code into any one of these different projects here, immediately the same thing will happen, and whatever you have mentioned as a Jenkins file will, or there could be a Jenkins file in here too. This actually is a Jenkins file. So this is a Docker app install Jenkins file, and this whole thing will be executed. If we put this Jenkins file name in the configuration here. In the configuration, you put the name of that Jenkins file, which comes from here. So this is that's repository is there. This and we change this to that, and then any change to Azure will kick off this Jenkins file and actually happen. So we are at end of our session for today. I will upload these slides today. I'll send the slides to Mickey, and he'll probably upload it to the to our Desktopper files area. So over to you.
Thanks, Partha, but we are late. I don't want to take up the time. Maybe we will do this survey in our next session, right? But if someone wants to fill up the survey link is available. Normally, the process that we do is we fill this together and we see the statistics together, right? As a team, that's the process that we follow. But nevertheless, I have sent the forms, the link, public link. You can go ahead and do it. And maybe in our next session, we can view this together. And the other thing is, for those who already have a Microsoft Teams account, you can go to the Codeathon, and then you can click. There is something called as a Fill Desktopper Community. So you can click here, and then you can do the the survey filling up, right? So if you get time, fill it up. If you don't have time, no worries. In our next session, we will take a 5-10 minutes break, and we will do this together. So the idea of doing this together is to really understand about all of us and how together in this team from different aspects, who is working where and what are the different aspects of different team members are together in this particular session, right? So that's the thought process. So let's do that next week. I don't want to take another 10 minutes of your time today. With that, we can close the session, Partha.
Kada, just one thing. Just talk about the job channel, please.
I've already said that in the starting.
Okay,
and I can
thanks.
also say that again. guys, we are startup and we wanted to create a community where we wanted to really help each other. All of us here, 20 people in this program, likewise in any other program. Please, in your company, if you have a jobs available, please put it here. If someone is interested, they will reach out to you. You can give some reference. If you help today, someone tomorrow, you might get help back, right? And similarly, if you believe there are some latest tech news that you wanted to share, put it in here. We wanted to really grow both the channels as a more engaging channels within our community. Thank you for your help in advance on that. Without further wasting time, we are trying to do our best to keep within the time. Every time we we go beyond the time, so that's why I don't want to do a survey, just to keep that promise. Let's do this survey together in our last session. Partha, in our last session, you are good to cover the rest of the topic and close the session?
Yes.
Perfect. So I'm looking forward to have all of you in our next session and do the survey together and get to know each of us together and continue to build this relationship in this open community. Take care, guys. Have a wonderful Saturday and talk to you all soon.
Thanks, guys. Thank you very much.
Thank you.
Thanks, Partha.
Thank you. Thanks, guys.